Okay guys, this is part two of the video of the engine assembly, and right now we're doing the rod bearings. And this is obviously a critical stage in the build. You got to get these dimensions right. If you get your bearing too tight, you can spin a bearing and end up kicking a rod out of the engine. So uh, we got a process here how we do this, and I'm going to go through it and show you how I do it, and it works real good. Um, one thing you always want to do is you want to check all your rods and all your mains. Don't just check one and think the rest are good, and don't check one on the main and think it's good. You have to check all of them if you want to do a thorough job and you want to know that your engine's going to live. So anyways, I did 7 already. We're going to do the 8th rod, and I had determined that we needed more clearance. So in the first part 1 video, I mentioned about the bearing clearances, how you can half shell, and that's what we had to do on this one. So we started off with the standard bearing, which would be a CB 743 HN on the Clevite brand, which I like to use. And then what we had to do is we had a half shell to get half more thou clearance. So this bearing is going to be a CB 743 HXN, and the X designates 1 thou over. So we're going to use half of the X bearing and half of the standard bearing, and that's going to give us the clearance we need. So basically, just like I mentioned before, it's going to be 1 thou per journal clearance. So these journals measure out your approximately 2.2. So if you go by the general rule of thumb, like I mentioned, it would be 2 thou and 2/10 plus another half thou would be 2 thou 7/10. That's what we're shooting for on the bearing clearances here. So what I like to do is I'll take my bearings out. These are already boxed up. They're already half shell. I got 1/2 of each. I got them there. What I like to do is I take lacquer thinner and I wipe off the back of the bearing. We'll do a final cleaning on these bearings later, but wipe it off. Then I like to, I got a marker over here, take a permanent marker, and I'll write number 8 for cylinder 8. This is so we can track them when we clean them. We don't get them mixed up with any other rods. These got to stay with the rod that you're checking. Okay, so now I got the bearings clean, bearings marked. Next thing I'm going to do is I'm going to mic the crank. I'm going to set this up so I can set up my dowel bore gauge. So this measures out right now 2 inches, 199 thousandths, and 4/10. So we'll put that in here. Next thing we're going to do is we're going to set up our dowel bore gauge. Obviously, this is a smaller one than I used for the cam. And we're going to set this up and zero it out. Double, triple check. Move it around. I got on 0. Okay, so now that's ready. Okay, the next thing I do, before I even, when I take these rods out of the box, these are scat rods, I mark them right away. I just mark one. I'll take a scribe and I'll mark cylinder 1, cylinder 2, 7 or 3, and I'll mark all the rods. So when we take them apart, we don't get the caps mixed up or anything. And then again, we can make sure that the bearing that we wrote on, that we're checking the clearances, stay together. So I already engraved the 8 on there. And now what I'm going to do is I'm going to take this rod apart. I'm going to put the bearings in, and then we are going to put the rod in the rod vise, and then we're going to torque it down. But what we also do is we check the stretch of the bolt, and that's pretty critical. Bolt stretch is absolutely, in my opinion, necessary, because the bolt stretch is most important. If you overstretch a bolt, then the bolt's no good, and you need to throw it in the garbage. And to get the most clamping force of a bolt, it's not just based on torque, it's based on the stretch of the bolt. And what's nice is Scat gives you a chart here, and they give you the different length bolts, different diameters of the bolts, and it will tell you the torque, and it will tell you the maximum stretch. So we're going to show you that here in a minute. But I already determined we have 7/16 bolt, and it's 1/400 long, and that's under the head. You measure underneath the head of the bolt, and it will be 1/400 long. So what I'm gonna do now is I'm gonna take this off from this rod vise, take it apart. Take this apart. And what I do here is just back this off about 1/4 inch. You gotta be careful doing this, but just tap on the bolts to separate the cap. Do a light tap. Back these off. And when we torque this, you got to make sure that you have ARP assembly lube on these threads. Some rods and rod bolts, they'll tell you just engine oil. Some dictate the ARP assembly lube. Just pay attention to what they say. I usually go, I do what they say. I do it different ways, and depends on the rod manufacturer. So then each bearing half is marked either upper or lower. This one is the upper, and the upper would be in the rod. So we'll put that on. Line the tang up on the bearing with the slot on the cap. Put that in. Now you got to make sure that the rod cap goes back on the way it came off, and where I engraved the 8 and the 8. You got to line them up. Bolts back in. And I'll just lightly draw this up. I don't really like to draw them all the way up. I'll tap it with the mallet like that. Close the cap so you're not pulling on the bolts. And right now, actually before I even tighten that up, see the bolts are loose. I'm going to check my stretch, which they give you on there. And what I like to do is where I mark the 8 on this. So this would be if you're assembling the motor and you're putting the rod in, this would be what I call to the outside. And so what I'll do is I'll check the stretch of this bolt, but what I'm doing is I'm really zeroing out my tool to start with. So the 8's there. This is what I call the outer. And then I'll see which bolt is longer right from the start. Okay, sometimes the bolt's longer and sometimes they're not. So right now these bolts are exactly the same. If they weren't, I would set my 0 to the shorter one, and then I would add in the difference of the length when I'm checking for my stretch. So right now, I'm going to 0 this out. It's on 0. Check it again on this side. Just double check. Make sure they're both on 0. Yep. So I got them 0 out. So what I would do is if the outer one was 0, which it is, I'll put 0. And if the inner one was 1, I would just write a 1 on there. And then when I would check my stretch, I would just add in that 1. But seeing the inner and the outer are both 0s, and I just write down 0, 0. And then the next thing I would do is put the rod in the vise, and we're going to torque it down. Now, I already did these, so what I did was they give you the basic torque with the ARP Moly Lube, 64 pounds. But I determined that if I go to 66 pounds, it's going to get me closer to my stretch, not to exceed the stretch. I like to get close to the stretch as possible, because then you get the most clamping force on the cap. So instead of going 64, I'm going to go 66. And then another thing I'm going to show you guys, when you torque rod bolts and the main bolts, like sometimes I'll tell you go in 3 steps, things like that, but this is what I found works best, and this is what I would do. Never fails. When I torque a bolt, I will go 1 swoop. I'll try to get right to my number on one swoop. I won't go, a little bit, check it, go a little bit more. Try to get right to your number on one swoop of motion. So I'm on 66. I'll bring these just snug. Now I'll go, and I will go until this thing beeps. Just like that, one swoop. Boom, 66. Okay, take the rod out. Now I'll check. I already got my gauge set, and we're going to check right now. This is the exact bearing clearance that we have. Perfect. 2/1000 and 7/10. Exactly what we got. Exactly what we're shooting for. And that we got that. We ended up getting that oil clearance because we half shelled it. It was like 2 and 2, 2 thou, 2 and 2/10 thou before I half shelled it, and I determined that's too tight. We don't want that. So we needed to loosen it up a little bit. And then what I'll do is I'll just write that down, and then all this is done. That's it. That's pretty much it. You do all of them. I just did the one, so you guys see how I did it, and that's how it's done. And that's how it's done. What we're going to do is we're going to put the main bearings in on the crank. We're going to torque them down, and we're going to do the same process. And I'll do all of them, and then I'll show you one, so you don't have to sit and watch me do all of them. But again, make sure you do all of them. Do all 8 rods. Do all 5 journals. And then you're not going to have no problems. Okay, I'm on the mains now, and I'm going to show you. I took the bearings out of the package, and actually I started off with an X bearing, which is a 1 thou over, only because I had an open package. What I usually do is I'll just put one cap on first. I'll just either put a standard bearing or 1 over or 1 under. I'll put one in there, and I'll check the very first one first, and that'll give me an indication where I'm at as far as machining and the diameter of the crank journals, to see if I'm even in the ballpark. There's no sense of just throwing them all in right away, and you check the first one, and then it's either too tight or too loose, and then you gotta, you could check them all if you had them on there, but most likely if the machine work is right, they're all going to be the same or really, really close. So to avoid extra work, I'll put one on, check it like I did, and like I said, I put a 1 over bearing in first, and it was too loose. It was 1 thou too loose. So what I did was I just took that back off, and I put just a standard bearing in there, and I checked it, and it's good. So now I don't have to, take off all the other 4 caps, and it's just a time saver. So now what I'm going to do is I'm going to put all the rest of them in standard bearings, and I'm going to go check, and then I'll write down the numbers, and then I'll decide on any of the other ones if I have to do a half shell or 1 over. Sometimes you do. Sometimes you might have a standard in the front, and then in the middle, maybe they're a little tight, and you have to adjust from there. But I try to get them all in, either all standard or all X, 1 over. But sometimes we got to half shell them. So again, like I showed you before on the rods, I just take lacquer thinner, I wipe off the back of the bearing, I write the number of the journals on there. That way when I take it apart, and if something, I throw the caps up here on the table, if they'll never get mixed up because the numbers will be on there. And then also too, you got to make sure that when you're putting these bearings in, that you're putting the bearings with the holes obviously on the bottom, because put the tang in first and push it on in, because you got the oiling hole there. If you make a mistake and you put this one down there and that one, then it's not going to get oil. It's not going to get oil to the mains, and then you're gonna burn up a bearing. It's going to happen real quick, and you're going to know right away that you made a mistake. So okay, so I just put the bearings in right now. I'm going to put the caps on. I already cleaned these. These are ready to go. Bearings in. Another thing I do here, if you notice, this car's clean, and I actually have these rags. These are from like a hospital that I buy, and super important to keep all your parts clean when you're assembling. I mean, the dirt and debris is your enemy. It's like the #1 killer of these engines. If you got all your clearances right, but you got some kind of debris in there, and you go to fire this thing up, it's going to eat up a bearing real quick. So keep your assembly area super clean, and you're not going to have no problems. Okay, the next thing we do is, I already done it here. I take the ARP lube, little brush, and I put it here on the threads, put it on the washer, and I put it on the nuts. And then we just put them in. I didn't do it yet, but before I do the total final assembly, I'll put anti-seize on these threads. But because I'm going to be taking these studs back out, I'm not going to do it just yet. I mean, you could put grease on the threads, assembly grease if you want on these threads. I know a lot of guys done that. And when you put these studs in, you don't tighten these studs down. These studs only go finger tight till they bottom out. Like this. That's it. You don't tighten studs down. Okay. You can check it, just give it a little, make sure it's bottomed out. Yes, that one's a little bit tight. Good, 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 good. Okay. Now, put the caps on. Make sure you get the right number. The arrow is always facing forward to the front of the block. Always. Should get the right one. Arrow forward. And this one's self-explanatory. Okay, now look at them in. What I usually do, I'm gonna tap. Just get them seated. Put your nuts on there. Your washers and your nuts. What I like to do, I just run them down with this. Save some time. Okay, now these are going to be torqued 110. And what I like to do, I'll go in 3 steps on these. I'll start at 40, then I'll go to 75, and then I'll go 110. And I'll show you how I do it. 40. And then I just go right down the line. I'll do them all. Then I'll go back for the second torque setting. I'll go down through do all the caps. This one's already done. I go to 75. Yeah, I'm doing it just one pull like that. Boom. These are done. I just check them again. Okay, now I'm going to go to 110. Okay. Okay, we're continuing on here with the main bearing clearances, and I already went through and put the bearings in, and as I showed you earlier that I did the first one and I put X bearing in, which is a 1 over, and it was too loose, so I took that off. I put in a whole another set, which was the standard bearings, and then I mic'd them up. Everything was looking good. This one and this one was good. I got to this one, and this one was still too loose. This one was fine, and then the last one where the thrust bearing is, that one was too loose as well. So in that situation, what I had to do is I had to put a 1 under bearing. I did what was called half shell in it. So I ended up putting on half of the bearing a 1 under on that one and a 1 under on that one, and I got my clearances spot on. I'm shooting for like 3 to 3.2, so somewhere in there. So so when I show you here on these part numbers on these Clevite bearings, so I ended up putting the full set of the MS 829H. That is the standard bearing. The H bearing is just the standard clearance, and this is what I put in there first. So the MS 829HX, this is 1 over. So to get looser, you would put the X bearing on. That's a 1 thou looser, but that was too loose, so I had to put this full set in. But the problem is 2 of them were too loose still at that point. So then what you got to do after that, this is MSH29H-1. This -1 means 1 under, meaning 1 tighter, 1/1000 tighter. But I didn't want to go the full 1/1000, so what I did was only used half of the shell, and that got me exactly where I needed to be. Now, one thing I need to mention here, what's very important if you're going to be half shell and bearings, you can only half shell, say for instance you started off with the standard bearing and then you needed to tighten it up. You can put a half shell of the 1 under with the standard bearing. What you can't do is go from an X bearing and half shell down to 1 under. You can't do like a 1/1000th jump. You can only do in half thousandths increments, which would be 0.0005. So you guys got to remember that. You can't half shell from here to there, but you can half shell from here to here, or you can half shell from here to there, and vice versa. Just remember that, it's pretty critical. But if you half shell, you can get your oil clearances spot on. What I'm going to do real quick, since I've already done them all, I'm just going to show you how I do it. It takes some time when you got some that are a little finicky like that. Sometimes I can throw in like a standard set, go right down the line, and all good. Sometimes, I got a half shell, and it just takes a little more time to get it. But in the end, it's worth it because you want to start your engine, your oil pressure be low, or having issues with your oil pressure. So anyways, this is what we would do, just like we did the cam and the rods. We'll take this on the number 1 journal, we'll mic it up, and I'll just hit the little lock on there. I like putting this little vise. Then we zero it out, like I mentioned before. Turn the little dial till it's on 0. Make sure you move this back and forth and so it's accurate. Right there, that's 0. Okay. Then what we do is we're going to check it on each side of the oil hole. And then we'll put it on this side of the oil hole, we'll check it. 3 thou. We'll go on the other side of the hole. 3 2. Perfect. Exactly what I was shooting for. So that's it. And then all the rest are the same too. And I did that with half shell on 2 of the main journals. So again, just to sum it up, basically it will be 1/1000 times the journal diameter. Take that, and then you add half thou. And for a street strip, performance engine, that's a good rule of thumb. You're gonna be good to go with that with those dimensions. So now that's all done. Now the next thing we're gonna do is we got to do the thrust bearing. Actually, that's real important. Almost 90% of the time, the thrust bearings are too tight on all these engines that I do. It just seems like, for whatever reason, that's just the way it is. Very seldom I can just throw a bearing in there and it'd be good to go. So I'm going to show you what I do there. We'll take the caps back off. We'll set the crank in there. We'll put just the rear main cap on. We'll tighten it down, and we'll check the thrust with the dial indicator. And if it's tight, I'm going to show you how I go about loosening it up. Now we'll actually sand on the surface real lightly and to loosen up that, and we'll use a dial indicator to check it. But that's it for this part of it, and then stay tuned for the next part. Okay, so we're on the part where I mentioned that we're going to start on the thrust. We're going to check the thrust clearance. So I already polished the crank. Crank is polished and also cleaned. It's really ready to assemble in here, but we have to check this thrust, and the thrust is really important because if you don't get the thrust right and the thrust is too tight and wears out, all the material from that is going to go into your rods and your main bearings, and then you're going to end up kicking a rod out because it's going to spin a bearing. This is real critical. You get this right. So anyways, I put it in there already and I checked it, and it's too tight. It's too tight like they always are. I mentioned that for some reason they're just always tight. But so anyways, I put the crank in there and I just put the bearing in the front and I put the bearing in the back, torque this cap down, and I put a dial indicator on the front here. And we're gonna check this right now. And I'm gonna show you, if you look at the gauge, I had it zeroed out, and I pry it the other way, and it's like 2. I like to shoot for like 6, somewhere like 4, probably 10 would be the max you'd really want to go. I'd put it right in the center, like 6, 7, 8 is a good number. So what we're gonna have to do now, we're gonna have to take the cap off, take the crank back out, take the bearings out, and I have a machine surface with some sandpaper, and we're gonna use really light grit sandpaper, probably like 200. And we're going to sand the surface of the bearings, and we're going to show you my method on how I do it. It works pretty good. So I'm going to do that right now. I'm going to take the cap off, take the crank out, take the bearings off, and then we'll go over to the machine surface and I'll sand it and I'll show you that. Now we're over at the machine surface, which is my shear here. And this surface here is machined. And I like to use this because it works out real good. As you can see here, I got different sandpapers on here. So what we're going to do here is I got this sticky back. This is what you would use on like a DA sander. I just stick it right to this, and this is 220. I'm going to start off with 220, and I'm going to show you my method, how I do this. I know other people have probably different methods, but this is what works for me, and I just stick with what works. So what I'm going to do on each half, this is the surface for the thrust on the side here. This is what we got to sand. And we only want to take a little bit off because we're already at 2 thousandths on our thrusts, and we want to get to like 6. That's really what we want to get to. So what I do is I'll put the sandpaper on there to make sure there's nothing on, gritty, anything on there to scratch up your bearing. And then what I'll do is I'll hold this on here in a circular motion. And here's the important thing: you want to count the rotations that you're doing. So I'm gonna go. I know I have to go a few thousand, so I'm gonna go about 10,000, 10 strokes. Go 10. I'm gonna turn it over. I'm gonna go 10. I'm gonna brush it off. I'm gonna take the other one. And I'm gonna go 10. I'm gonna turn it over, and I'm gonna go 10. Then I'm gonna take them over to the solvent tank, clean them, put them back in the engine, put the crank back in, check it, and see where I'm at. What I like to do is when I get to, say if I'm shooting for 6 and I notice I'm at 5, I'll change the paper to 400. So I'll go from 220 to 400, and I'll do my final, closing in on my thrust clearance with the 400 grit, and that takes any scratches out of the surface. And then we'll clean in the solid again, we'll put in the engine, we'll check it, and then when we get to where we want to be, then we'll do a final cleaning, and that will be ready for the final assembly. So I'm just going to show you how I do it here. I'm going to count out 10. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, barely took anything off. I'm going to turn it over, dust it off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's one half. I'm going to do it on this same one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They barely still shade, little shade there, so I didn't really go much. I'm going to do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. Now what I'm going to do is I'm going to go clean them in the solvent tank, put it back in the engine, check it, see where I'm at, and if I'm close, I'm going to switch the paper to 400, and I'm going to finish it off and get it in that the last few thou. Okay, we're back at the engine. We just sanded the thrust on the bearing. I cleaned it in the solvent, and I put the bearings back in. I haven't even torqued the cap yet. But what I want to do here is I wanted to show you this part of it because I want to show you 2 things. One is when I torque this cap, I'm going to snug up the bolts, and then I'm actually going to hit the crank back and forth with the mallet, because what that's going to do is if your cap is on there a little crooked, it's going to square it up to the block. And if that's not square to the block, it's going to change your thrust clearance. So I'm going to snug this up, tap it, then we're going to torque it, and then I'm going to put the dial indicator on there and show you guys exactly how many 10 strokes, how much it changed it. I had it set at 110 for the final before. I got to go back to 40. I'm going to go 40, 75, and 110. 3 steps on the torque. So right now I'm just going to snug it. I'm not even torquing it to 40 yet. So I just got a little bit of pressure on there. What I'm going to do, I'm going to take mallet, that squares the cap. I'm going to torque it. Go to 75. Now 110. Okay. Now what I'm going to do, put the dial indicator on there. I have it set it up already. And if you remember, we had 2 thou before. Now I'm going to check it and see what we at. And remember, we did 10 strokes when we were sanding it. Now we're at 4. So that tells you 10 strokes with 220 grit sandpaper gave me 2 thou. Still too tight. I mean, this is 4 thou is the bare minimum. I mean, you could probably run it there, but I wouldn't run it there. I like to be at 6. So what I'm going to do, I'm going to take it back out, and I'll probably go 5 strokes with a 220, and then I'll switch over to 400, and then I'll finish off that, and we're going to shoot for 6. So that's that. We'll go do that right now. We did the final sanding on that. Like I mentioned, I did 5 more strokes, and I switched it over to 400, and we did the last, and it turned out perfect. I'm going to show you guys. It's actually like 6.5 thou right now. If you look at that, I zeroed it out. Boom. So if you count your strokes, basically 10 strokes was 2 thou. And then I did it again, and then I did 5 strokes, and then I did the rest with the 400. The bearing is completely smooth, and now we got the exact thrust clearance that that we need. Another thing you can do too, I do sometimes, I'll mark 90 degrees over from my my indicator, and I'll turn the crank 180, and I'll check it, and it should be the same. Sometimes you might gain a 1/2 thou, but it's just good if you're on the tight side, just to rotate it and then check it out. Another thing that's important too that I didn't mention that I want to mention is this dial indicator. When you put the dial indicator on here, you want to have the indicator 90 degrees to the crank. I mean, you could have it off to the side, but your measurement could be off. So it's just good practice when you're doing something like this. Put your indicator 90 degrees to the crank, check it, and you'll be good to go. So this is done. So this part is done. The next thing we're going to do is we're going to take the crank out, and we're going to check the rear main seal. Lately, I've been having problems with rear main seals. I've been putting Felpros in there, and I don't know if it's a manufacturing defect or what, but they've been too large or too big. And when I tighten the cap out, they actually pushes the seal out, and you're going to have a leak for sure. So I'm going to show you that, and then the next thing we're going to do after that, we're going to file fit the rings, and so that's coming up next. Back on the engine here with the rear main seal, and I wanted to show you a few things about this that recently I've been having problems with these rear mains. I'm using this Felpro 2904, and I like to use this. This is what I've always used for a street engine, one that's not with a vacuum pump. If we had an engine like a race engine with a vacuum pump, we would use a Viton seal, and it would be like brown in color. But here's the situation. And I check these all the time now, because if you don't check this, you're going to have a leak. And here's the problem. These seals end up being too long, and there's too much crush on the seal. So whenever you put these seals in, you want to make sure that the lip is facing towards the inside of the engine. Like that. This lip goes in. And then whenever you put this seal in, you need to use this little shoehorn that they give you with it, so it doesn't cut the backside of the seal. So I'm going to push that in. I got that little shoehorn in there, and I'm push down. And then I'm going to push it down until this side is level. Now here's what I want to show you. I'm pushing down on this. See the stick up right here? This has X amount of stick up, and then the one on the cap has X amount sticking up past the block. The problem with that is when you have too much of that sticking up on both sides, you have too much crush. When you tighten the cap down, what's going to happen is the ends, the butts, will push out, and you'll 100% have a rear main seal leak. I mean, there's no way around it. It's going to leak. And there's nothing pisses me off when I get these engines done. I get them up on the dyno, and I got a rear main seal leak. And it could be a cause from align honing the main journals and machining the caps, but in this situation, that is not the problem, because this block has been align honed, and the cap's just been barely dusted. This block has never been align honed, so you can see just minimal amount has came off of that cap. And here's what I want to show you. I'm gonna measure this one, and then I'm gonna put this one in and measure this one, and I'm gonna show you like basically the stack up of how much crush would be in there. So if I have that level, and then I measure this,
It's about 45 thousandths sticking up. We'll call it 40. We'll even be generous there. We got 40 there.
Then we'll come back over here. And we'll put the other half in the cap. Again, using your little shoehorn here so you don't damage the seal. Push it down. I'm going to make one side flush. See, it's flush. And now look. Look at this stick up there. So I had 40 on the other side. I'm going to measure this one. 50. 90 thousandths crush. And you can see if I was to tighten that down, these would actually buckle out and this seal would be distorted. So 90 thousandths is way too much crush to have for this, and your 100% is going to leak. So what we're going to have to do here is we're going to have to take, I like to take just one of these seals, and I got a belt sander. And it's a sketchy proposition. You got to be really, really careful. So anyway, we're going to put it on the belt sander. We're going to put it down here, and we're going to sand this down. And the magic number that I figured out is 40 thousandths. So we're going to sand this down. So total crush is going to be 40 thousandths. So basically, what I can do here, because that one was sticking up 40, 45, and this one was sticking up 50, what I'll end up doing is I'll take the whole 50 off this one. I'll take 50 thou off. So this one here will be flush with this or slightly above. And then that one will be sticking out 40, 45 thousandths. And when I bolt on the cap, it's going to work perfect. You're going to have no leaks. Just 90 thousandths just is way too much. And it's nothing to do with the machine. It has everything to do with this Felpro seal. Back in the day, I would use these all the time. I wouldn't even check them. I'd throw them in. I never have a leak. And then all of a sudden, start throwing them in, put it on the dyno, things spitting out oil all over the place. Get the engine off the dyno, drain the oil, take the oil pan off, investigate, and then this is what we came up with. And now I've been checking every single one that I do. And what we'll do is we'll walk over to the belt sander, and I'll show you how I do it. And we have to do that almost at every single one now. But if you hold that 40 thousandths crush, you will never have a problem. You just got to make sure when you sand this, you got it perfectly square, and it looks, there's no nicks on the edges, or you don't rotate it or anything like that when you're sanding it. So we're gonna take a walk over the sander and show you that part next. So now we're over at the belt sander, and what we're gonna do is we're gonna turn the sander on, and we're gonna just barely hold it. But when we hold it, we got to hold it square because we have to sand that so it's perfect. We don't want to rock it one way or the other way, and it doesn't take much because this is basically silicone rubber seal. That's it. I ain't gonna take much more than that. I'm gonna go over there. I'm gonna put it back in the block or in the cap, and I'm gonna measure it again, and I'm gonna keep doing that until I have this seal flush with the cap, where the other one's already sticking up the 40, 45 thou, which is gonna be perfect for the crush. So we'll walk back and we'll check it. So now I'm back from the sander, and I got the seal back in the cap. I'm pulling down. I got the one side flush. This was 50 before. Now it's a little over 30. So we got to go a little more. As you can see, it doesn't take much to get that, to take anything off this seal. And you can see it's still perfectly square. So we're going to go back to the sander and do it again. We're back here with the cap after I just sanded it for the final time. And now we're going to put it in here to double check to see where we're at. So push that down. There you go.
That's perfect. So these are flush with the cap. And then over at the block, it was sticking up like 40, between 40 and 45 thou. That's perfect for the amount of crush that I want. And then when we go to put this in the final time, when we put the cap on, what we'll do is we'll put a little sealer behind each seal, and we'll put a small dab right on the ends. And we'll put the seals in there, and we'll be good to go. This thing 100% will not leak if you do it like that. And we're going to show you that because we're going to run this thing on a dyno, and you're going to see we're not going to have no leaks. But what I will do here in a minute, I'll put the seals in, I'll put the cap on with no crank in it, no bearings in it, and I'm going to show you what would happen if the seal was too long. I actually have another seal I'll put in there, and I'll show you what it does. And actually what happens is when these are in there like this, these ends here will want to flare outward because there's just too much material and you're trying to clamp it down, and it has to go somewhere. And what that does is it will end up leaking right here. It won't even matter how much sealer you have on it, because basically what happens is the seal becomes distorted. And by taking off the material, it won't be distorted no more. So I'll put another seal on there, one that's not sanded. I'll torque it down, and then I'll show you. Now we're back here. I actually had another seal. I took it out of the bag and checked it, and actually this one wasn't even as bad as the one that I actually sanded. This one had 60 thousandths crush, and as I mentioned, the 40 thousandths crush is the key number. Now this one had 60, and I'm going to show you, I'm going to tighten down this cap, and I'm going to show you what this does when these seals are not right. It's going to buckle right here, right on the split line. So I'm going to take this down. I'm not even torquing the cap, I'm just drawing it down, and you're going to see. And this is why they end up leaking. If you look right there, it's bulging out on both sides. And this one isn't even as bad as this one was 60 thousandths crush, and that would definitely leak. So this one would need sanded as well. Okay, so I'm getting ready to put the crank in now for the final time, and I started putting the bearings in. I just got to put the thrust bearing in now. Like I said, make sure that you got the holes for the bearings, on the block side, and then make sure you get oil to your bearings. Just a couple quick things before I put it in. I want to show you guys. I got everything ready to go right now. Everything's clean. The crank is cleaned, polished, cleaned. I have anti-seize on the studs, on the threads that go in the block, and then on the other side it's got ARP assembly lube on those. And then the seals are cleaned, and this is what I use to put on the bearings, this Clevite bearing guard. I'll put them on the bearings. You could use the actual engine oil too if you wanted, but if the engine is going to be sitting for a while, I would use this. If you're going to start it right away, then you could just use engine oil, and that would work fine too. And then we have to put some sealer on a little dab on the ends of the seals. And this is what I like to use, the right stuff. I use this throughout the whole engine, everything. I don't change to RTV silicone or anything like that. Just use this, and you're going to be good. So use these two things, and then for the valve train stuff, I use this high pressure lube. This is what you would want to put on like the rocker arm tips. Anything with high pressure, I will put this on. This is like real sticky, and it works real good. So that's pretty much it, man. These three things is really all I use, and then the sealer for the freeze plugs. I showed you guys that, and that's it. Over on the cart, all the parts are clean. They're ready to go. The rods, the bearings are with the rods respectively. When we check the bearing clearances, they're all together, all cleaned, ready to go. So what I'll do is I will let the camera roll, and I'll just work, and I'll put the crank in. You guys watch how I do it, and we'll put them all, put the crank in, put the caps on, go through, torque them all, and then that part will be done. And then this will probably be the end video for part 2. I'm not trying to make them really long. I'm going to try to keep them where you can watch them in stages. And then part 3, I'll probably do the filing of the rings, and we'll start putting the pistons on the rods, and then getting the pistons in the block. So that's it. Part 2, man. Hope you guys are liking it, and stay tuned for part 3.